Hello and welcome to the tutorial explaining the software contributions of our manuscript titled End-to-End Computational Approach to the Design of RNA Biosensors for miRNA Biomarkers of Cervical Cancer. In this repository, there are three major contributions. The first being the grammar parser, which can, when provided with the toehold switch sequence, nucleotide sequence, and its dot bracket notation, output the 9 different domains of the toehold switch. The second is the predict.py file, which consists of the coefficients of the variables that determine the on-off ratio based on our multivariate regression model. And the third one is the toehold efficacy predict.sh file, which is a shell script that invokes core utilities, VNRNA tools, as well as the grammar parser and predict.py files. So the first thing to do with respect to using our software is to download the code onto your local system, either as a zip or clone it using Git. And as you can see, I've already done that here, where I've got the entire repository in my local system, and I've opened it up using an IDE. So the usage of this particular repository is pretty straightforward. There is only one file that needs to be run, and that is the shell script. So I'm just going to clear my terminal here and run the shell script. And I get a prompt to enter my switch sequence. So in this example, we'll be validating the switches provided by Takahashi et al. 2017. And as you can see, they've provided both the switch and the triggers. So we will be making use of this and validating our model. So I paste the switch sequence followed by the trigger. Note that these are DNA versions of the toehold switch sequences, and this does not matter because VNI, RNA, and other utilities ultimately pass this into RNA, and case also does not matter. So I run this, and as you can see, the script has outputted the engineered features as well as the predicted on-off ratio. Now let's just take a look at the script to really understand what is going on. So with respect to the first few lines here, we get the switch and the trigger sequences as input and validate the corresponding user input using regular expression patterns. And we make use of Vienna RNA's RNA fold program to come up with the switch and the trigger minimum free energies. And keep in mind that we constantly write out the output of our programs onto independent temporary files that will subsequently be deleted after the script is run. So we output the switch and the trigger onto separate files, and also output a concatenation of the switch and the trigger using the ampersand symbol, which is useful for serving as an input for the RNA cofold program, which can predict the minimum free energy of dimer structures. So the switch and the trigger is written out into a file as a dimer, and the dimer's minimum free energy is calculated using RNA cofold. Most of these programs are quite similar because they all make use of the VNRNA packages that essentially accept inputs as files as well as independent sequences, and we just grep out the values that we want instead of receiving the full output of these programs. So in a similar fashion, we make use of shell commands and echo commands to come up with the sequences and the MFE values of these of our input sequences. Next, as you can see here in line 51, we're making use of the grammar parser tool. This is essential for two key features that are of interest to us. So the grammar parser is capable of outputting 9 different domains, beginning from the toehold domain and ending in the linker and everything in between. But what is of interest to us is to have the grammar parser output the bottom region of the toehold, which is essentially the dimer between the 5' end consisting of the toehold domain and the ascending bottom stem, and the 3' end consisting of the descending bottom stem and the linker. Similarly, the grammar parser can also output the RBS linker domain sequence, which is the sequence from the RBS loop to the 3' end of the linker. And correspondingly, the RBS linker MFE is calculated using RNA fold, and the bottom region MFE is calculated using RNA cofold because it is a dimer. And finally, we invoke predict.py, which can output the final on-off ratio using the 6 features that have been engineered using the toehold efficacy predict.sh program. And these are passed as command line arguments, and the coefficients that are depicted here are multiplied to each of these values and added to the final intercept of the program. And lastly, we print out the on-off ratio value and remove all the temporary files that were created in this process.